Hey guys, welcome to Unit 3, which is all about quadratics continue. So for 3.1 is called the zero property law, or sometimes you might see it as the zero product law. Same exact thing. So our objective today is that students will be able to use the zero property law to solve quadratics. So first thing we need to know is, what is the zero property law? The zero property law says if the product of any multiple factors is equal to zero, then at least one of those factors must equal to zero. Keyword, at least one. The zero product property can be used to find where the quadratic crosses the x-axis, which is what we call the x-intercept. So let's see a few examples how this works. Example 1. Remember, this is when I factor a quadratic, I will have something that looks like that at the end. So all the zero property law says is I want to solve these. So I have two factors, which are x plus 7 equals to 0. This is addition. Or I have x minus 3 equals to 0. And from here, these are simple one-step equation where I minus 7 do the inverse operation. 7 are cancel, x is equal to negative 7, which is one of my answer, and in here I would add 3 on both sides. This is cancel, x is equal to 3. So this is telling me if I was to graph this quadratic into a calculator, I will see at x equals negative 7 and x equals to positive 3, those are where the graph crosses the x-axis. Let's look at B. Again, I have 2x minus 5 equals to 0, and I have x minus 4 equals to 0. Okay? So simple. This is a two-step. Add 5 on both sides. This is cancel. 2x is equal to 5. Get x by itself. I do the inverse, which is divide by 2. X is equal to 5 over 2. That's one of my answer. Here is a one step, add 4 on both sides, x is equal to positive 4. So what you're going to do, guys, is pause this video. Yes, Miss Amaru says pause the video, and I want you to try this one on your own, okay? Give it like less than a minute. Pause it, and then tell me what you got. So now you got a chance to try this. I wanted to point out something. You should have gotten x equals to negative 2 over 3 and x equals to 3 over 4. Now, what about this 4? This 4 that's outside here. That doesn't really have an impact on the answer, and which we're going to answer in our second example. It says the zero product states, remember what it said? It said that at least one factor must be equal to 0. It does not mean that all the factors, at least one of them needs to be equal to 0. So if a factor is a constant, then it has no effect on the solution. The reason why one of these factor needs to be a 0 is because when I multiply by 0, I will get 0. So the zero product law can be used to solve any quadratic equation that's factorable, meaning it's not prime, and it will give me something that looks like this in the end, which we did in Unit 2. Now let's see how this works. Solve each of the following quadratic equation using the zero product law. So remember, when we talk about quadratic, I am looking for something that's in the form ax squared plus bx plus c equals 0. The first thing I ask myself for example A is this equation given to me in this form? Since not, I want to move all of these over so I can have something that looks like this. So the first thing I want to do is move the x. So I do add 2x on both sides because I do the inverse. I like to draw my reverse. So I have x squared plus 5x minus 14 is equal to, these cancels off and I'm left with 10. Now I want to get rid of the 10, minus 10 on both sides. My 10 cancel, 0, which is what I'm looking for, looking better. This becomes x squared plus 5x minus 24. Perfect. Now that I have this, I want to say what's my A, what's my B, what's my C. My A is 1, my B is 5, and my C is negative 24. Make my X, because I need to factor these, A times C in the top, which is minus 24, and then my 5 in the bottom. So this is where I'm going to go ahead and think two numbers. When I multiply it, I get negative 24, but when I add them, I get a positive 5. And you will see it works out to be a positive 8 and a minus 3. Excellent. So because A is equal to 1 right here, I know that I can just write these in factor form, which is x plus 8 and x minus 3. But because the question asks us to solve it, I'm going to keep it as equal to 0. Now this is just like we did in the previous example, where I take both of these, x plus 8 equals to 0, and x minus 3 equals to 0, and I solve these. So these are simple one step. I'll get x equals to minus 8, and x is equal to positive 3. So all that means is if I was to graph this quadratic right here, if I was to graph this, these would be the point where it intersects your x-axis. Now let's look at B, which looks a little bit more complicated because I have terms all over. So remember, the key term, and let me just draw a line here so we can do our separate everything, is to get it in this form right in the top here. So I'm going to start by moving the x squared, bring my river, minus x squared on both sides. Remember, I can only combine like terms. These are cancel. I am left with 2x squared plus 12x minus 7 equals to 3x minus 2. Let's get rid of the 3x, minus 3x on both sides. This is cancel. I'm left with 2x squared. 12 take away 3 is 9. Good. 9x, bring down my minus 7. Last thing I'm left with is a minus 2, so I'm going to do the inverse, which is adding 2. These are cancel. I got 0, which looks good like up here. 2x squared plus 9x minus 7 plus 2 will give me a minus 5. Now that my equation, this is going to be my what I'm working with now right here. I have that. I want to say what's my A? My A is 2, my B is 9, and my C is negative 5. Now I want to do my X, negative 10 in the top, and then positive 9 in the bottom. Two numbers, when I multiply it, I get negative 10, but when I add it, I get a positive 9, and those numbers are 10 and negative 1. Good job, guys. So remember, now that A is greater than 1, I just can't do what I did on this side. I have to replace my B term. So I will want to write 2x squared plus 10x minus 1x minus 5 equals 0. I want to replace my B term. Now why do I do this? Remember, A is greater than 2. And then I'm going to factor 2x out. I am left with x plus 5. Good. Here is I'm going to factor out a minus 1. I'm left with x plus 5 equals 0. And then don't forget, they're the same thing, so I rewrite it once, and then I have 2x minus 1 equals to 0. And this is what we see in exercise 1. So all I'm going to do is solve these. So I'm going to do x plus 5 equals to 0, and 2x minus 1 is equal to 0. So, simple one step, minus 5 on both sides. 5 cancel, x is equal to negative 5, which is one of my answer. Here is a two-step, add 1 on both sides. This is cancel. 2x is equal to 1. Divide both sides by 2. 2's are out. X is equal to 1/2. So these are my two x-intercept, or where this quadratic crosses the x-axis. So moving along now. The zero product law is extremely important to finding the zeros or the x-intercept. So example 4, the parabola shown to the right is the equation of y equals x squared minus 2x minus 3. Write the coordinates of the x-intercept on the graph. So all I'm looking for is where on this graph intersects your x-axis. So this is my x-axis, and I'm looking, this is 1 point and this is 1 point. So I know this is my center, so I can see I go one left, so one of my coordinates is at x equals -1, and then my other coordinate is at x equals 1 to +3. And it will always be x equals something. So we can check if these two answers are actually correct, and that's what we're going to do in B. How do we find this algebraically? So algebraically, all it means is similar to what we did in the previous example. So I want to take x squared minus 2x minus 3 and make it equal to 0. And again, this is a quadratic, so I need to factor it. My a is 1, b is -2, c is -3. Factor this out, I get -3 on the top and -2 on the bottom. So I want to find two numbers. When I multiply it, I get -3, and when I add it, I get -2. Those numbers are -3 and 1. Since a is equal to 1, I can just write these factors out. X minus 3 and x plus 1 equals to 0. Once I write these out, I can go ahead and solve them. X minus 3 equals to 0, and x plus 1 equals to 0. Add 3 on both sides. X is equal to 3, which is what we have up here. Minus 1 on both sides. This is cancel. X is equal to -1, which is our answer up here. And again, these points coordinate to these right here. And here's our last three examples for today's lesson. First one says y equals 4x squared minus x. Algebraically, I want you to find the x-intercept, or basically where the graph crosses the x-axis. So the first thing I want to do is set this up. 4x squared minus 1 is equal to 0. And if you remember, these are actually 2 squared minus x squared minus 1 squared. And these are my difference of square, 2x minus 1 and 2x plus 1 equals to 0. If you don't remember the difference of square, you can do it as a equals 4, b equals 0, c equals -1, and so forth. But it's just easier to solve with this. So now that I have this, let's go ahead and solve these. So this becomes 2x minus 1 equals to 0, and then 2x plus 1 equals to 0. 2x is equal to 1, x is equal to 1/2. Okay, here 2x is equal to -1, x is equal to -1/2. So these are my two x-intercept for the first one. Let's go ahead and try B. So it's going to be 3x squared plus 13x minus 10 equals to 0. Now let's say my A is 3, my B is 13, and my C is -10. Make my little factor x, -30 in the top and 13 in the bottom. So we all know these numbers. These numbers are -10 and -3. But be careful here, a is equals to 3, so I will have to replace my term, my b terms, which is this 13x. So I have 3x squared minus 10x minus 3x minus 10 equals to 0. factor, what do these have in common? An x, so I'm left with 3x minus 10. These have nothing in common, so they have a 1 in common. 3x they have a positive 1 in common, sorry. Minus 10 equals 0. Remember, if I had this as a negative times a negative will be a positive, and I need to have a negative, so this has to be a positive 1 in common. So, once they have that, 3x minus 10, same thing, and then it's x plus 1 equals 0. Then the last step that I need to do is just make these equal to 0 and solve these. So 3x minus 10 equals to 0, x plus 1 equals to 0. I have 3x is equal to 10, and x is equal to 10 over 3, which is my first answer. And here, minus 1 on both sides, x is equal to negative 1, which is my second answer. So, there's one more question for you to do, which is C. I want you to pause the video and tell me if you can figure that one on your own before you start to do your independent practice. I'm pretty sure this was way easier than you thought. So, the first thing I want to do is set my equation equal to 0, which is 5x squared minus 10x, my 5x squared minus 10x equal to 0. If you look at it, they both have a 5x in common, so what I did, I just factored it out. I didn't even have to go through the A, B, and C. And then I said 5x equals to 0, and x minus 2 is equal to 0. Divide both sides by 5. 0 divided by 5 is 0, which is my first answer. And then I have add 2 on both sides, and my second answer is x minus 2. So once you got that, you know what to do. Work on your independent practice. Good luck, guys. Remember, you can do this.